If there was one thing that could be changed when it comes to flights, most travelers would probably say the seemingly endless hours spent in the sky. So, what if that time could be substantially cut? Boom Supersonic, the US plane manufacturer, plans to have the answer with its new Overture jet, which is set to transport customers at twice the speed of today's fastest commercial aircraft and is regarded as the new Concorde. Today, we will talk about the latest developments from Boom and how these advancements are bringing the world closer to the return of supersonic passenger travel. The idea of a supersonic passenger airplane first emerged in the late 1950s in France and the United Kingdom. France's Sud Aviation and the UK's Bristol Aircraft Company have begun independent research in this area. In 1962, French and British parties signed an agreement to jointly develop and produce a supersonic passenger airplane. This project was named Concorde. The airplane was designed to meet stringent speed and range requirements. Concorde had a characteristic arrow-shaped wing and a narrow fuselage, which allowed it to reach speeds in excess of Mach 2, double sonic speed, and reach a range of 4,488 miles. The first test flight occurred on March 2, 1969. The Concorde prototype took off in Toulouse, France, and a few weeks later, on April 9, 1969, it took off in Farnborough, UK. Serial production began in 1971. 5 years later, the first commercial flights were launched. Concorde catered to premium passengers and offered luxurious facilities on board. In comparison, the plane was flying between Europe and North America in 3.5 hours, while other passenger planes took more than 7 hours to cover the same route. Neither before nor after Britain and France decommissioned the legendary Concordes could any passenger airplane even come close to their normal speed. For comparison, the current record among subsonic civilian airplanes belongs to British Airways' Boeing 747, which traveled this route in February 2020 in 4 hours and 56 minutes. Nevertheless, the Concorde stopped being built back in the 1970s and stopped being operated in the early 2000s. Why? The problem was, first of all, their high cost. Technical development and production of new airplanes turned out to be much more expensive than it was supposed at the initial stage, and only government intervention saved the creators from collapse in the 1970s. Another reason was the fuel crisis of the 1970s, which made it less cost-effective to operate voracious supersonic aircraft. As a result, their production was discontinued in 1979. A total of 20 such aircraft were jointly produced by the French and British. All of them served the long-haul destinations of Air France and British Airways until 2003. It did not add to the success of airliners and the fact that the authorities of many countries by that time had already banned flights at supersonic speed because of the noise that the airplanes created. Simply put, the supersonic Concorde rattled in a way that made the devil sick. Many people living near Heathrow Airport still remember how in the 1970s, when a Concorde took off or landed, they couldn't hear what their teacher was saying while sitting at their desk at school. And on Sundays between 10 and 11 a.m., priests in nearby churches interrupted services, not out of a sense of awe at the miracle of French-British aeronautical ingenuity, but because they couldn't shout this miracle over. The supersonics were finally killed by a new jump in global energy prices, and in the early noughties, their era ended. Of all the companies that have tried to develop and build a successor to the Concorde over the years, only one has come close enough to actually doing it. Founded in 2014, Boom Supersonic is a commercial airplane manufacturer that aims to make supersonic aircraft affordable for business travel. The company's ultimate goal is a routine supersonic flight for everyone. company's XB-1 test aircraft provides the foundation for the design and development of Overture, Boom's supersonic airliner. XB-1 leverages state-of-the-art technologies to enable efficient supersonic flight, including digitally optimized aerodynamics, carbon fiber composites, advanced supersonic engine intakes, and an augmented reality vision system for takeoff and landing visibility. The purpose of the XB-1 is to provide data for the Overture, which is intended as the 21st century successor to the retired Concorde, only this time one that is economically viable and with a fuselage design that turns the infamous sonic boom into a sonic thump. This would allow Overture to operate over land routes in the United States. Let's take a look at the company's achievements over the past year in chronological order. On March 22, 2024, Boom Supersonic announced the successful first flight of XB-1. XB-1 took off from the Mojave Air and Spaceport, California, and flew in the same airspace that hosted many historic first flights, including the flights of the Bell X-1, the North American X-15, and the Lockheed SR-71 Blackbird. XB-1 met all of its test objectives, including safely and successfully achieving an altitude of 7,120 feet and speeds up to 273 miles per hour. In addition, in July at the Farnborough International Air Show in the UK, Boom unveiled Overture's flight deck, built around technology from partner Honeywell, and predicted it will have a full-scale engine core operational by 2025. The company also announced it secured a Symphony assembly and testing facility through an expansion of its existing partnership with Standard Aero. Overture's state-of-the-art flight deck runs on Honeywell's Anthem avionics suite, which is also the system of choice for electric vertical takeoff and landing (eVTOL) aircraft manufacturers Lilium and Vertical Aerospace. According to Boom, it will be the first airliner to feature force feedback side sticks, which give pilots a physical response to the aircraft's movement as well as inputs made by the co-pilot or autopilot. Like something out of a science fiction film, Overture pilots will don augmented reality goggles during takeoff and landing. The headset, built by Universal Avionics, uses multiple cameras and sensors to fill any gaps in the pilot's vision. Boom says this is intended to eliminate the droop nose configuration seen on aircraft such as Concorde, the only successful supersonic airliner in history. The views seen through the goggles will also appear on the flight display, and an auto-landing system will assist pilots on the way down. Breakers and buttons are replaced by high-definition 17-inch touchscreen displays, while some physical controls such as stick, throttle, and landing gear remain. However, Boom says all aircraft functions can be accessed through software, which will receive routine over-the-air upgrades. Already, the new flight deck has been tested by real-world airline, business, and military pilots, including Mike Bannister, the former chief Concorde pilot for British Airways. Bannister flew more hours on Concorde than any other pilot and has now become the first pilot to fly both Concorde and Overture. "I've long believed that Overture is the rightful successor to Concorde," said Mike Bannister, sharing his unique perspective on supersonic flight. "After experiencing Overture's flight deck, which is incredibly well designed and delightful to fly, my excitement and enthusiasm for this aircraft has only intensified." Separately, Boom gave several updates on the progress of its Symphony engine program, most notably that it expects to have a full-scale engine core operational within 18 months, despite unveiling the program less than 2 years ago. Symphony is the purpose-built turbofan engine that will enable economical and reliable supersonic flight on board Overture, Boom's supersonic airliner. In October 2023, the Symphony team successfully completed the engine's conceptual design review. This paved the way for hardware rig tests, which are now underway. The company will collect data on the core via testing, which will inform the development of other components, such as the compressor and turbine section. Those parts will come from newly announced partner ATI Inc. Fuel nozzles and other 3D printed parts have already been produced, and Boom has begun testing certain hardware components. It plans to conduct more than 30 engine hardware rig tests with partner Florida Turbine Technologies, FTT, which helped design the technology. Symphony engines will be built and tested at a Standard Aero facility in San Antonio, which Boom projects will one day include 100,000 feet of manufacturing space. The company plans for its partner to produce as many as 330 engines per year. Blake Scholl, founder and CEO of Boom, earlier said that each Symphony engine will have about 3 times the combined power of the XB1's 3 J85 engines. Engine type is just one of many design differences between the XB1 and the eventual Overture vehicle, not the least of which is size. Scholl calls the XB1 a 1/3 scale prototype demonstrator for Overture. He says the XB1 is helpful in validating simulator data, and its development has already borne fruit in the design of Overture, even though the two look nothing alike. If your prototype looks exactly like your production airplane, it means you haven't learned anything. And we've learned a lot from the XB1 through design, development, and manufacturing that has led us to improve Overture, said Scholl. In August, XB1 successfully completed its second flight. The landing gear was retracted and extended in flight for the first time, which is typical of second test flights. The XB1 team also assessed aircraft handling qualities and demonstrated a new stability augmentation system, or roll damper. This roll damper was implemented to improve handling qualities based on learnings from first flight. Most recently, on December 13th, XB1 successfully completed its 9th test flight, reaching a new top speed of Mach 0.87 and clearing critical system checks as it approaches supersonic flight. XB1 reached a new maximum altitude of 27,716 feet. Flight 9 focused on clearing flutter points at increased speeds and varying altitudes to ensure the aircraft structure continues to behave as predicted in the expanded flight envelope. This type of testing measures the interaction of the aircraft structure with the atmosphere it is flying through and is critical as XB1 continues to reach higher speeds. This flight successfully demonstrated updates to the Flutter Excitation System, FES. During XB1's previous test flight on November 16th, the team gathered key insights about the flutter testing equipment and incorporated improvements into the design of the FES. The team diligently refined tools and processes, many of which need to be created from scratch for the unique needs of XB1 to ensure the safe and effective envelope expansion of the first independently developed supersonic jet. These modifications enable a safer and more efficient progression through the transonic and supersonic regimes in the remaining test flights. The company anticipate an additional flight to accomplish all safety checks prior to supersonic flight, which they are now targeting in early 2025. Boom aims to fly Overture in 2026 ahead of a planned 2029 commercial rollout with airlines worldwide. The company's flagship model is intended to carry from 64 to 80 passengers at Mach 1.7, just over 1,300 miles per hour, twice the speed of subsonic airliners, while cruising at 60,000 feet. Blake Scholl previously told the New York Times that the company's goal is to fly passengers anywhere in the world within 4 hours for just $100. Concorde, for comparison, flew at Mach 2.0 and cost passengers thousands of dollars per trip. Unlike Concorde, though, Overture can run on 100% sustainable aviation fuel. The aircraft will only fly at supersonic speeds over water, since the FAA has banned those flights over land. However, If the technology proves successful, the ban could be reviewed. So far, Boom has racked up more than 130 orders and pre-orders for Overture, including from United, American, and Japan Airlines. And what do you think about this project? Share your thoughts in the comments below. Also, if you enjoyed this video, don't forget to like it and subscribe to the channel and turn on notifications to stay connected. And thanks for watching.